chapter 3. We did finish chapter 3. What was I going to say? We're going to start, as you can see, the next chapter, which is chapter 5. Okay. So we have that. I will post problems from the, numbers, that is, from the textbook that you can do for practice if you want. I'm not sure if I think the last section I posted actually was in chapter 2, so I got to catch up with that. Okay, so let's go on to chapter 5, okay? Okay, so let's see. All right. Okay, so here, what we're going to do is we're actually going to see what an angle is. And you're also going to see what radians are. I mean, the formal definition's in the book, but I'm not going to go into the formal definition, mostly for time consideration. And trigonometry I'm going to go into as well. Only right triangle trigonometry. I mean, you actually could define trigonometry beyond angles in a right triangle. And I know they do that in pre-calc, which is Math 105. In this class, though, even though it's in the book, I'm not doing that for time consideration. Because again, they do that in Math 105. So, but you do have to know right triangle trig going into Math 105. So that's why I'm going to go through that. Okay. All right. So again, this is, I think it's chapter 5 in the book. I mean, yeah. All right. So anyway. So basically, let's say we had a line, okay? We're going to see what a ray is. It's essentially part of a line. I mean, I don't want to say half of a line, but I guess in a sense I can. Although that may not be precise because lines, don't have finite measurement. Basically, you could form a line this way. You take any line, okay? What you do is you take a point on that line, and then you're going to take all points on the line on one side of that point. So you're going to have like a point. You're going to take all points on the line that are on one side of that point. And the other side you're going to throw away, basically. And that point becomes an endpoint. And we have here what's called a ray. Okay? This is what we call a ray. So that's what we get here. All right? Now, how do we form an angle? Well, we actually rotate the ray about that endpoint, okay? We actually rotate the ray about that endpoint, okay? That's what we're going to do. And the starting position of the ray is the initial side. Where it ends up is the terminal side. Basically, you're going to have something like this. This is the initial side. This is where the ray starts, okay? This is where you start. So to say, the starting position, the initial side. And then after you rotate, you're going to get to what's called the terminal side. That's the ending position of the ray, the terminal side. So you're going to rotate. The end point will become the vertex of the angle. So you're doing some kind of rotation. As you can see, that's what the green arrow here is trying to indicate. And an angle is really just a measurement of rotation. That's really what an angle is, essentially. When you rotate about some point, you're forming an angle. And this green arrow here is indicating that you're going to go this way from the initial to the terminal side, as opposed to doing something like this, which you could do, of course. But I just wanted to be clear here. Okay. Theta here, okay? That's what this symbol is, theta. T-H-E-T-A, it's a Greek letter. Usually Greek letters like this we use to denote angles. That's really more of a convention that people do. So, but this is what we have with angles and stuff, okay? All right, so that's what really that's what an angle is. I mean, the book does go a little bit more into it, like, for instance, drawing an angle in what's called standard position. But again, that's pre-calc. I'm not going to go into that. Okay, but we want to be able to measure angles. In other words, what units are we going to use, right? We have units for different things like length, which is measuring distance, right? We have miles, kilometers. What about angles? Well, there's two units that we use. One of them is mathematically nice. The other one is not mathematically nice, but we're more used to it. Degrees is not mathematically nice, but we are used to it. Radians is the unit for angle measurement. Mathematically, it's very nice, but maybe because it's new and people aren't used to it, it's not really hard, it's not really easy to visualize, but you'll see what I mean. For degrees, there is a formal definition, but really, let's just think of it this way. If you imagine the initial position of an angle is this, rotating counterclockwise. So you're going against the clock, counterclockwise about the vertex. You're doing one full complete rotation so that the terminal side is on top of the initial side. So again, you're rotating the initial side, okay? Rotating completely all the way around about the vertex, okay? Counterclockwise, doing one complete rotation. By definition, you have the angle is said is 360 degrees. So in other words, we have formed a 360-degree angle. And then 1 degree is 1 over 360 of this complete rotation. You know, rotating about the vertex counterclockwise. Okay. Now, I'm pretty confident that's the formal definition of a degree. I mean, it's not, you know, it's not the nicest, so to say, but that's okay for now. Notationally with degrees, we use a little circle and we raise it almost like an exponent. So like over here, for instance, 1 degree is notationally 1 raised to a little circle, as you can see here. So 360 degrees is 360 raised to a little circle. Okay. It's just notation. I know it looks like an exponent, but it's really not. So that's just notation for it. But 360 degrees is a complete rotation counterclockwise. And here's some other examples. 90 degrees is 1/4 of a full rotation counterclockwise. So it's going to look something like this. That's what 90 degrees is. 180 degrees is when you rotate and you're facing the opposite way. In other words, you're going to do half a full rotation counterclockwise. So the terminal side is pointing this way, and the initial, you know, opposite the initial side. Okay. That's just what, again, it's by definition, it's half of a full rotation, half of a complete rotation. You know, it's basically you're facing the opposite direction. Can you rotate clockwise? You can. By definition, then the angle will be negative. But again, we're not really going into that. So counterclockwise, the angle is positive. Clockwise, you have a negative angle. And that's just a definition. Okay, good. So that's what we have with angles. Now with the radian, okay. Well, actually, are there any questions so far? Okay. With a radian, there is a formal definition, but again, I'm not going to go into that for time consideration. I mean, it's really not terrible, but you know, it's not as nice as you hope, I guess, so to say. But it does turn out to be mathematically very useful. Mathematically, it behaves very nicely, radians, a lot better than degrees do. But for now, let's just focus on converting between degrees and radians. Okay? It actually turns out that 180 degrees is the same as pi radians. So 180 degrees is actually the same as pi radians. But again, that's not the definition, but it turns out that way. And from there, you can get these equations. 1 degree is pi radians over 180 degrees. Again, we get that from here. Basically, you divide both sides by 180 degrees. And theta degrees turns out to be theta times pi over 180 degrees. And in a similar way, 1 radian, okay, is 180 degrees over pi, 180 over pi degrees. So theta radians is theta times that. I know this is all like probably confusing what I've written. Really, the bottom line is this: to convert from degrees to radians, you want to multiply by this. Pi times 180 degrees. Pi over 180, excuse me. You want to multiply by that to go from degrees into radians. Okay. And to go the other way, to go from radians to degrees, so if you start out in radians and you want your answer in degrees, you have to multiply by 180 over pi. That's what you want to do here. Now, it is tempting to convert pi to write it out in decimal form. Don't do that with radians. You basically don't do that here. Also, I know I put it up here, but I didn't put it here. It's really good to make sure that when your angle's in degrees, make sure you have the degree symbol. You know, you write it out in degrees. You write the degree symbol here. I didn't do that here, but you really want to make sure you do that. There's no notation for radians. So if you don't see the degree symbol and you know it's an angle, then you can assume that the angle's in radians. I mean, why is there no notation for radians? I honestly don't know. But generally, people who work in math or sciences, they work in radians, not degrees. All right. Okay, so that's how you convert. And that's really the main idea here, to go from degrees to radians and radians to degrees. So, okay. All right. So, for instance, let's say we want to convert angles, okay? So let's say we have 90 degrees, right? We want to get that in radians. Before I do that, let me just stop this.